Assalamualaikum. My name is Zahira Amira Zamzuri from AT282A. I would like to present about IoT solutions for real-time nutrient analysis for my AGR491 oral presentation. I will explain about introduction, description, explanation, elaboration, conclusion, and reference of this prototype. So, as we know, most of the nitrogen in soils comes from animal manure and fertilizer. For example, nitrate, which is the most common type of nitrogen that is plant available in soils. During rainfall or irrigation, the nitrogen quickly flows through the soils, leaching and flowing off into the surface and groundwater. When the concentration is high, it could cause a contaminated environment and eutrophication. In addition, now we already have Internet of Things (IoT) that employ unique identifiers such as transmitting data across a network to interact. This will help the farmers to monitor and control their soil quality with a cellular device. Next, description. So, what is IoT soil sheet for real-time nutrient analysis? It is an IoT-enabled sensor platform for accurate real-time measurement of nitrate leachates in soil. It has sensor sheets that were inkjet printed on a paper substrate, and the working electrodes were pyral electrode plated for nitrate sensitivity. The sensor sheet consists of 8 electrodes in a 5x3-inch area, while electronic sensing is enabled via microcontroller and IoT network. The sensor sheet will transmit measurement data to a cloud server and mobile device via Westmode ZP Pro SMA 5 dBi radio and a Meshlium Zigbee Pro access point. Next, explanation. This wireless sensing platform was demonstrated by detecting the soil leachate levels in 3 samples of limestone-derived eudolten soils with known carbon and nitrogen content with respect to irrigation cycle. Firstly, the sensor was placed 1 inch beneath the soil bed surface, and then the reading was recorded 600 seconds after irrigation to allow the leachate to reach the sensor. Thirdly, irrigation was applied at a consistent daily rate, and bottom drain leachate samples were tested for 6 consecutive irrigation cycles. Fifthly, the sensor's reaction to different irrigation cycles indicate the leaching rates. Then, when the sensor reaction is high for 2 consecutive times, an alert signal is delivered to the IoT network via an external microcontroller. And lastly, data from individual sensor is sent to the Meshlium access point, where it is kept locally and transferred to a cloud service. Next, elaboration. Leaching trends were found to be similar within all 3 soil samples, with the first 2 irrigation cycles having the highest levels. This might be caused by loosely bound nitrate. The sensor response has been classified into 3 levels based on the nitrate leach rate, that is, low, medium, and high. However, after 3 consecutive tests, the sensor stability was discovered to be degraded. This might be due to the pyral surface degradation. In conclusion, IoT soil sheets for real-time nutrient analysis are currently addressing the sensor abnormalities as observed from the experiments. These abnormalities can be caused by various factors such as the concentration of soil nutrients, pH, ionic composition, weather conditions, and soil microbial interaction. However, this sensor sheet was successfully created as IoT enabled and might open up the possibilities for networking arrays of sensors in order to obtain stochastic data on various soil components. And that's all from me. Thank you.